All right, can everybody in the back hear me? Okay, so welcome to LOWLINC Speaker Series. We're really excited. I love all of our Speaker Series presentations, but this one's especially delicious. So thank you all for being here today. I see lots of members and volunteers and also some guests. So can you share, if you're a guest here, raise your hand. All right, welcome. Thank you so much for being here today. How many are here for the first time? Okay, fabulous. As you may or may not know, LOWLINC has been around for just over 10 years, and we're a virtual village, and so we operate on the concept of neighbors helping neighbors. And so we're helping each other age in place, and through that means some member services like transportation, friendly visits, tech assistance, and also lots of social activities and fun, and educational events like today. So if you're interested in learning more about LOWLINC, we have brochures on the back, we have member and volunteer applications in the back. So don't hesitate to reach out to any of us to ask questions. I'm Jean Camo, by the way. I'm the executive director of LOWLINC. I've been with LOWLINC a little over 3 years, and I love being here. It's a fabulous community. I'm going to share a couple of upcoming events. You don't necessarily have to write them down because you can go to our lowlinc.org website and look at scroll down a little bit and look at the calendar, and you can see the dates, times, locations, and how to register. But I wanted to point out that we're having an Ask the Doctor series in addition to our speaker series. Last month we had Dr. Hardy, a cardiologist from UVA Health, and coming up, March 25th, is it? No, I think it's...
Yeah, it is.
Okay, March 25th. Okay, thank you. We're having Dr. Ure, a urologist from UVA Health, and then in April, we don't know the doctor's name yet, but there's going to be an orthopedist. So we hope that you'll come out for those. And those, so far, it's been a great series. Of course, our monthly speaker series is also open to the community every month, the first Thursday of the month, so we hope you'll continue to come out for that. Our music memory and music program, which is open to LOWLINC members and volunteers, we're excited to continue that. So on March 24th, I hope I got that right. Jane's over there.
Sorry, speaker series?
No, the
Music memory. Tuesday the 24th.
Tuesday the 24th. Okay, good. I have some things memorized, but and so that's going to be our next music memory movement program, and we're going to. I don't know if you've seen it on the internet or not, but it's sort of chair dancing. So we're going to move to the music of the 50s, 60s, and 70s, and I know it's going to be a lot of fun. I love to dance, so I'm super excited about this one. And then we're partnering with Aging Together to do brain health, interactive brain health program. Is going to be right next door on April 8th from 10 to 11:30. And then before too long, we're going to circle back to our drum circle because that was really popular. So stay tuned for all those activities. Let's see. I want to make sure I don't forget anything here. Jane, is there anything important that I'm missing?
No, we haven't.
Okay. So I want to say thank you to Jane Capone. She's our our member services coordinator, and she does a great job of supporting the call handlers and therefore supporting our members and volunteers every day, all day. Some days are busier than others, and really appreciate all that she does. But is there anything else that you want to mention?
Well, the jewelry swap is...
Oh yeah, the jewelry swap. So it's jewelry and handbag, first ever swap. And do you know the date on that?
Community Center, Tuesday on St. Patty's Day.
Okay.
Yeah.
So that's
1 o'clock.
Yep. So just you go to our online calendar and you can check out the date, time, and register. So all right, I want to give a shout out to our videographer, Charles. Thank you for recording this, and this will be up on the website within a week or so, hopefully sooner. And I also want to give a big thanks to the Health and Wellness team, and they host this program each month, and there's a lot of logistics that goes into making sure that our presenter is all set and making sure that this comes off as well as it does. So thank you, Health and Wellness team. And with that, I am going to turn this over to a member of the Health and Wellness team, Lynn Fogarty, who will introduce our presenter. So again, thank you for being here. Look for resource materials on the back of the table before you leave, and don't forget to hand in your survey. I'm not gonna be here, but these guys will make sure you hand in that survey. So thanks again. All right, Lynn Fogarty.
As she said, I'm Lynn Fogarty from the Health and Wellness Committee, and it's my pleasure today to introduce Kelli Slunt. You may recognize the last name. She is related to Emily. She has been here before, and it was such a big hit, we decided to do it again. I think you're all going to enjoy this. Kelli teaches at Mary Washington, and she has since 1996. She's had many papers published and set up many courses, and she has a PhD in chemistry, bioorganic chemistry. But her special interest is the chemistry of food. Mine is just food. I failed chemistry. And she swears she's going to teach us how or why we have certain cravings. So that I do want to know. So I'm going to turn this over to Karen.
Thank you for that kind introduction, and thank you for inviting me back. It's my pleasure to be here. I'm going to be running back and forth so that I can advance the slides. But and if you have any questions as I'm speaking, please don't hesitate to ask, or feel free to hold them till the end. Either way is fine with me. We're going to be doing a number of activities as well.
Would you like me to advance the slides, please?
If you would, that would be great. All right, thank you. That would be terrific. Thank you. I appreciate the offer. All right, so we'll go ahead and get started. If you want to move to the... Perfect. So my objectives of today is that we're going to explore the science behind taste and flavor, learn a little bit about your sensations of taste, smell, and other factors that really do affect your experience and enjoyment of food, and then discover a little bit about food pairing, which I think is an interesting concept. Okay, next slide. All right, so we have different senses, and in terms of our different senses, one, of course, is anything for pleasure or reward. So enjoying a meal, some might say smelling the roses, or that cool feeling of eucalyptus vapors. So those are using different parts of your senses. And then, of course, warning and danger in terms of food. One of the biggest things, of course, is to know if food is spoiled, so the taste or the smell would direct that to you. If there's a fire, perhaps the noxious odors of the smoke. You're cooking and happen to notice something's burning, or burning odors of ammonia. You're cleaning your house, or heaven forbid they have to use that in the hospital to get your senses going. But those are definitely some of the things that your senses can detect. Next slide, please. So we're going to talk today about flavor, and there's really two main contributors to your flavor. One is what we call taste, and taste is all that really happens in your oral cavity on your tongue, pretty much. So you all may have been familiar with your taste buds. So that's pretty much what I'm talking about today when I use the term taste. But then odors are what are happening in your nasal cavity. And both of these are going to play a big role in your sense of taste and your enjoyment of food. Okay, thank you. So what are consequences of loss of flavor? And of course, this is definitely something that came about. I think more people started becoming aware of this during the pandemic, when individuals were losing their sense of taste. But also, as one ages, you often see a loss of flavor. And so what can happen there is then one of two possibilities happen often. that you can just start indiscriminating eating because, nothing tastes very good, and so why consume food if it's not pleasurable? And what can happen as a result of that is weight loss, but more importantly, malnutrition really could be a downside of that. Or you could do compensatory eating, where you would be trying to use whatever flavors you can taste. So for a lot of people, this is increasing your sugar, increasing your salt, things that you can still detect. And then, of course, that could lead to opposite problems of weight gain, but also you could have malnutrition, even though you're eating, sweets and things. Yeah, ask away.
I've been saying that for years, that my taste is fading.
Yes.
And I turn more to like red pepper and hot sauce and things like that
Sure.
I can really taste in my mouth.
Oh yeah, and then of course there with the red peppers and things, which I'll talk about in a little bit, you're not only are going to those flavors, but pain, because you can still experience the pain, and that's one of the things they say about, that you're still feeling something. Yeah. No, absolutely. That's probably a healthier thing, and as long as your gut can handle all the spiciness, than high salt or high sugar. Yeah. And please, like I said, I tend to talk fast, I get excited. Please interrupt me like that if you have comments or questions. But we can go to the next slide. So this is one of my favorite quotes. Taste is not a single sense, not separate from its fellow senses, from aroma, texture, shape. The qualities of taste are intertwined, widely complex. If I were to ask you to describe olives, cheese, apples, I don't think you can. No word, no image, no simile will do. And apples don't remind us of fall. Fall reminds us of apples. So just as I said, I think that it's kind of an interesting quote by Sally Tisdale, who wrote The Best Thing I've Ever Tasted in terms of taste. All right, next slide. All right, so as I said, there's different components of flavor perception. Taste is one, aroma is the other, but then you also have your nerve senses. So that's what I was talking about in reference to the pain, and that doesn't have to be necessarily unbearable pain. Even, as I said at the beginning, that cool sensation of eucalyptus vapors. That is still your pain receptors that are detecting it, but it might be a pleasurable type of nerve sensation. Hearing and vision, we interact differently with food that looks unpalatable versus food that looks good. The first sense you sometimes have is seeing what your food looks like, but also textures, and especially individuals change their relationships with textures. I remember one of my children, my daughter, for the longest time would not eat meat when she was like 2 or 3 years old because she hated the texture of it. Now she loves meat, but everybody has different relationships with texture. And then environmental conditions. I know that seems surprising, but environmental conditions definitely can affect things. There's been some studies that if you put the same hot chocolate in 2 different color mugs, people find one is creamier than the other, and there's nothing different about it there. Think about, how pleasurable eating a meal sometimes in a restaurant is compared to home, even if it's basically the same food. So environment plays also a role in your perception with food. Thank you. All right, so I'm going to try to read through this. This is a Big Nate cartoon. So the first part of it says, what's the blindfold? What's the blindfold? And he said, we're testing Nate. He claims he can identify any food strictly by smell. He's, so sniff, sniff. Tuna on whole wheat with a slice of tomato. He's got it. Sniff, sniff. Ham and Swiss and lettuce on a sesame bulky roll. Wow, with just a smidge of honey mustard. Here, try this. Sniff, gag. Oh, this is foul. I have no idea. Are you sure this is even food? That question has been asked many times. This is why I never buy hot lunch. So, again, like I said, I mean, that's a terrible cartoon, but it's again this idea of, we do eat by our senses and what it looks like and smells like. All right, thank you. All right, so these are our chemical senses that I'm going to spend a little bit of time today on. Taste, smell, and chemesthesis. And chemesthesis is really that idea that I was talking about in terms of pain. So those are going to be the three we're going to look at. All right, so taste. And taste buds have been long studied. It used to be thought that like the front end of your tongue was used for certain tastes and the back end was for other tastes. They now have decided that all of your taste buds all over your tongue actually do detect these certain chemicals is what they're detecting. Your tongue only can detect the things that are on this slide. So, and the first I'm going to start with are the ones you are probably familiar with. So the bottom kind of, I don't know, close to about 7 o'clock-ish on there, sweet. So if we start with sweet, everyone should be fairly familiar with sweet. And if you're interested in the science, and I'm not going to go too far into it, but that little thing that looks like a cartoony squiggly line, those are receptors that are found on the taste buds, and that they detect the sweet molecule binding to them, and that elicits a neuronal response. So if a sweet molecule binds to it, and of course you all may be familiar with artificial sweeteners and things of that nature that have been developed that also bind to that receptor and trigger that response. Then if we move counterclockwise, sour, again, should be something that everybody is relatively familiar with. These are going to tend to be things that are acidic in nature. And so from a chemistry standpoint, that's looking at pH. And so something that has a lower pH than 7 is considered acidic, and it would trigger the receptors that detect that increase in the proton concentration. And so things that are common, the sours, most of you would be familiar with citrus, your vinegars, because that's acetic acid, so those very sour things. But also your stomach acid is acidic, so we have those even in our body. Then if we keep moving, bitter. So bitter is detected on the tongue, and it could be poisons. So a lot of things that are poisonous are bitter. Bitter is mostly detecting kind of the opposite end of the pH spectrum, so it's going to things that are more basic. And so some of your drugs and poisons are actually bitter. But also there are naturally occurring chemicals that are bitter in broccoli, in coffee, things of that nature. Then salty, we're all hopefully familiar with salty. Again, another receptor that detects the presence of salt. Then the last two have been more recently added. Umami. Umami is it's detecting actually glutamate. So glutamate is an amino acid. It's also a neurotransmitter. So if you remember, I don't know when it was, but MSG, if any of you have heard of MSG, MSG is monosodium glutamate. So that's all it is. It's just monosodium glutamate. It's the salt form, because sodium is one of our ions, and the glutamate would be the other part of the salt. And so MSG is used as a flavor molecule, not as much now because there's issues with it because it is a neurotransmitter. So if you get too much of it, people used to get agitated and sweaty, and when they, especially the Chinese food syndrome, because it was used a lot in Chinese food. But they've determined that glutamate molecule is what elicits that response, and that's why it's a flavor molecule and why it's been added to foods. But it's naturally occurring in cheeses, mushrooms, tomatoes, beef, those sorts of things, because it's an amino acid, so it's part of your proteins. And so proteins that have a high amount of that elicit that umami response. And so even like soy sauce and things like that. So if you think about that response, that's what umami is. And then they've now decided that they want to add fat as something that your tongue detects. And so it's mostly, this is partly a detection, of the tongue, but it's more of like a mouthfeel. So, some people really like to eat fatty foods, and they like the way that those fatty foods feel. And so they've added that as the last thing now that your tongue detects. So I think we can move forward. All right, so one of the things we're going to start with today in terms of an exercise is looking at super tasters. So, one of the things that I've been fortunate to do at the university more recently is we have a summer enrichment program for high school students. So they come to the university for a week, they stay on our campus, and they take a number of classes. I teach a food chemistry class, so we actually spend a little bit more time. And so one of the things they do in the first day is I have them paint their tongues blue with food coloring, and then they go into the bathroom and they count their taste buds in a circular, basically I take one of those hole punch protector things, put that on their tongue, and tell them to count what's inside the circle, because that will actually tell you how many taste buds you have per square part of your tongue, square inch part of your tongue. And the more taste buds you have, the more likely you are to be a super taster. We're not going to paint our tongues today. But one of the other things you can do is you can use strips. And there's technically, you can get a kit of up to 4 strips. I only went with 2 of the strips today. So we're going to try these strips, and they have a chemical on them. And this chemical, if you are capable of detecting it, comes off kind of bitter. And it was discovered once in a lab where they were working with this, and some of the workers could taste, it kind of puffed up in the air, and some people were like, oh, that tastes terrible. Others didn't taste it at all. And they started to see that there was this correlation between the super tasters can taste this and others can't. So if you're a super taster, it means, as I said, you've got a high number of papillae on your tongue. So if you want to go home and paint your tongue with a Q-tip in blue and count the little things inside a square, you feel free to do that. Just be aware it takes forever for the blue coat to get off of your tongue. But anyways, but you can experience flavors, especially very bitter ones, with a greater intensity. And so some people who are super tasters, they really don't like certain types of food, broccoli, coffee, things that are really bitter. They have a hard time eating them because they're a super taster. Studies also suggest that women are more likely to be super tasters than men. So we can move to the next one. Then, of course, related to what we've been talking about, though, there could be some individuals that are non-tasters. And a non-taster would have very low taste buds, and they really don't perceive flavors as intensely. They still may perceive some, but they're not very intense. And again, this is getting back to that issue that perhaps food would not be pleasurable for you. And so you may need to have spicy, highly seasoned, or high-fat foods in order to enjoy that. All right, so if we go to the next slide, what I'm going to do is I'm going to pass out the strips, and I will tell you one of the strips is a control piece of paper, so it should just taste like paper. The other strip has the PTC chemical in it, and if you are a super taster or a moderate taster, you should taste a bitter taste. But I'm not going to tell you until later which one is which, okay? And so you'll record your perception. You may want to wet your tongue. I think there's some water around, or I have little cups if anybody needs water to do this. All right, hopefully by now you've tasted both of them. Thoughts?
The second one was really bad taste.
The second one was really bad tasting. All right, and then I have others who are saying can't taste either. I can't taste either. They both taste like paper to me. Yep.
This one is
The first one is the control paper. The second one has the PTC. So if you are able to taste the second one, if it tastes bitter, you're a super taster. So, how many of you are super tasters? Wow. Okay. It's phenylethyl, I forget what it is exactly, PTC. PTC. Yeah, so you can see it up there on the slide. I just got them on Amazon. They're available, on the Amazon. All right, so we can go to the next slide. I would say probably in terms of super tasters, about 25% of the population is a super taster. Some of you who may be tasting bitter might be on the not quite a full super taster, but you're definitely not a non-taster. So about 25% of the population is a non-taster. All right, so in terms of aroma, as I had talked about a little bit and alluded to it, we can detect over 1 trillion molecules in our nasal passage. So our sense of smell is pretty large. But as I talked about with that one quote, the thoughts are we can't describe them all. So, if somebody were to ask you, how was that dish? Or how did you enjoy your meal? You might say, what? Good, exactly. I mean, that tends to be it was good, it was pleasant, it was, and then you do have some people who, and I've never been able to do this, and it's probably because I'm not a super taster, but you go to a winery and they say it has notes of honeysuckle and whatever in it, and I can't detect those things. And can't describe them, but some people can.
Tastes like wine.
Yeah, exactly. But but some people can pick out these flavors and things. But and so in terms of how this affects our sense of taste, there's actually 2 ways in which you encounter these molecules. One is orthonasal, which is from the front, and so we can kind of see on the picture on the left, the food molecules are there, and they're going in through the nose and going up into the nasal cavity, and your brain is detecting them. The other way, though, that you can detect them is retronasally. So you put the food in your mouth, you're chewing it, and the flavor molecules go up the back of your nasal cavity and are detected. So you actually have both of those playing a role. And of course, this is why when you have a cold, you can't enjoy your food, generally speaking, if your nasal cavity is blocked.
I have an anecdotal question of this.
Mm-hmm.
My grandmother used to keep cinnamon buns in her freezer, and she also kept mothballs in there, and in her basement. And when we ate the cinnamon buns at her house, you couldn't taste mothballs. But when she would give us a pack to take home, they tasted like mothballs. And it was always been a mystery. I always assumed it had something to do with that. Would that make sense?
I mean, it could. It also may have to do with, I don't know. I mean,
if her house smells like mothballs.
Right. Oh, so if her house smelled like mothballs, you probably adapted to the mothball smell and then only focused on the cinnamon.
So that tracks? Okay.
Yep. Yeah, absolutely. Yeah, very interesting. I was also trying to figure out if it was how it was packaged and if it was sticking on there, but I bet you go in, because eventually you don't detect smells. Your body just gets used to them.
Would it be your brain thinking, you just subconsciously always associate mothball
Oh,
smell?
with grandma's house. Yeah, I mean, that could be too. I mean, yeah, absolutely. I saw something in the back.
I wonder if they make liquid medicine taste so bad on purpose, or it's just an accident? I mean, is there a reason?
Well, most of it is when I was going back to the fact, most molecules that are medicinally based are very bitter. And so a lot of them, several of the medicinal based compounds come from plants. and they often give plants those bitter tastes and things. And like, for example, caffeine is actually highly bitter. And so a lot of the drugs are based very similarly structurally to that. And so that is more what it is, not, and then they try to flavor them, but it sometimes makes it worse, it depends.
No, I just don't understand. Send a man on the move, but he can't make medicine taste okay?
Well, no, it's the nature of, because some of the things is your body naturally does not want, so bitter was evolutionarily developed to prevent you from eating things that are bad for you.
I was wondering if that's why they did
And
it.
so these drugs have that bitter taste partly because
They don't want you
you
too much.
eating it. Your body doesn't want you eating it.
Right.
So,
Okay.
so you really can't remove that bitter taste.
Right.
All right, anything else? All right, next slide, please. All right, so what we're gonna do next is I have some containers that all contain essential oils. So these are essential oils that have come from some kind of plant. Some of them might be a food aroma, some of them might just be a plant aroma. So we're gonna pass them around and you're gonna just open them, smell them, and try to record what you think it is. Okay? That's a really good question. The question was, if somebody's a super taster or their aromas you can smell better. I don't think there's a definite correlation because they're different receptors. So your tongue has, the taste buds that are picking up the super tasting thing. The aroma is due to receptors in your nasal cavity. And there are cases where, I didn't bring them with me, but spearmint and caraway. So, spearmint has that, mint, caraway rye. So they are what we call, I'm holding up my hands because they're handed molecules. So one is like your right hand, one is like your left hand. They are identical except for that fact. And some people can detect one, but they can't detect the other. So, and I don't think it has to do with their taste buds, I just think it has to do with your nasal receptors. Yeah, that's a good question, I don't know, but that's a really fascinating question. Very pleasant, yeah. No, they're all relatively pleasant essential oils. I didn't pick anything noxious. 3, this will be the flavoring 1 and flavoring 2 to figure out if it is the vanilla extract or the imitation vanilla flavoring that you can purchase instead of vanilla extract. Taste the vanilla. It says to record odor and taste, but I'm going to pass around something in a few minutes that you can taste. That's a bitter. That's usually, sometimes it's a bitter, or it's just residual sticking to your taste buds. Or that the predominant flavor leaves your mouth and then something follows. So like, for example, when we were talking about spicy foods before, the capsaicin in the peppers binds to your taste buds and blocks a lot of other things. And then that's why fat, like milk, sorry, I was gonna come around with more. Fat dissolves the capsaicin and takes it off of your taste bud. So that's why fatty sour cream, milk helps out. Everybody finish the odors, not the vanilla, but did everybody finish the first odors?
Haven't seen.
The first set, not the vanilla. Have you done the A through G?
Oh, yeah.
Okay, everybody's done A through G. We're waiting on the vanilla. I know everybody's waiting on the vanilla. All right, so here's your identification on the next slide. So, A was peppermint, B was rose, C was sweet orange, D was lemongrass, E was lavender, F was cinnamon, and G was jasmine. All right, so I come from a university with an honor system. Who got all of them right? How about 6? Oh, we got one with 6. Or green.
Let's go with that. Get it spicy.
How about 5?
Like the orange.
All right, there we go. We have our other winner.
That's why I got an extra one. I already thought it smelled lemon. Lemongrass.
All right. So keep working on the vanilla, and I'm going to go. Any questions on that?
100% lemon.
I got the bitter, you know, I could taste
Uh-huh.
the bitter, but I didn't get one right.
You didn't get one right. That means your tongue works and your nasal passage doesn't. Can you go to the next slide? So, one of the big things that you all may realize is that your sense of smell, your ability to detect odors declines significantly with age. So, and you can see that here on this slide. And so,
We're on a downhill slide.
you cheated. So, that is, of course, and a lot of you may have said, I still taste with my tongue, but I'm not smelling or detecting odors, and that is probably related to age, degeneration of the receptors in your nasal passage. Now, one of the things they do say is that you can train your brain a little bit to kind of do odor therapy. So if you know of an odor and you smell it a couple times a day, and you can kind of sometimes retrain your brain a little bit to detect those things. So, you know, if you really want to and you take the scratch and sniff stickers, you can scratch and sniff them for a little while until their odor goes away. But at least that might help you. How do you know that's true? I can't tell you that, but they won't last forever just because of the way they're impregnated with the chemicals. Any questions on that? All right, yeah.
I noticed a decrease in smell and taste after having COVID.
Mm-hmm. Yeah, so the question was a decrease in smell and taste after having COVID. They do know that that's a side effect of the COVID virus, that it does impact. It's mostly that it's impacting, I believe, your odor receptors, and that's why you're losing that. Why, for some people, it comes back versus others, that's still unclear what the virus, I mean, I'm not fully certain what the virus is doing there.
Injections or whatever.
Mm-hmm. Oops, if you need another spoon, there's some on the back.
But I didn't follow what she said.
If you have the coronavirus vaccine.
Oh, that also inhibits
yes.
your.
Oh, so for some people, the vaccination
It does
affected
a
it.
lot of bad
Okay,
things
Oh, okay.
to your body.
okay. Next slide, please. All right, so I briefly mentioned chemestasis, and our 2 winners, I gave you chili pens that show you on there the structure of capsaicin, which is the molecule that is responsible for the pain that you experience if you eat red chili peppers or chili powders. But then also, as I mentioned, there's other molecules that'll cause some chemestasis to occur. Menthol gives you that very cooling feeling. Carbon dioxide, for some people, is they can't tolerate it because the gas bubbles kind of give a form of pain on the tongue. So, but you know, all of that is kind of playing that role in chemestasis. All right, next slide, please. All right, so natural versus artificial flavors. So I'm passing around to you natural versus artificial flavoring. And so natural means that it's isolated directly from a food source. Artificial means it's produced in a laboratory. All right, if we can go to the next slide. So you all are probably familiar, and what I'm passing around to you are these 2 samples. So one is McCormick's Pure Vanilla Extract. And you can see based on the ingredients, it's vanilla beans, extract in water, and it needs to be in alcohol because a lot of the molecules are not water soluble. And so that is why alcohol is added to that, is to make sure that the extract, especially the vanillin, which is the chemical that's responsible for the flavor that we associate with vanilla, is there. All right, so let's see, the vanilla needs to go to the next row. Or have you all had the vanilla?
I have.
Okay, can you pass it to the third row?
Oh, sure.
Thank you. So then vanilla flavor is water again. It has alcohol in it. Vanillin, as I mentioned, is the molecule that is associated with the flavor of vanilla and other artificial flavorings. So one could ask why. Well, look at the price difference. So, I mean, there is a big difference in terms of price between using pure versus the artificial. All right, so if we go to the next slide. And so sources of vanillin can come from all sorts of places. Doesn't have to come from the vanilla bean. It can come from the vanilla bean, but of course, as some of you may know, vanilla beans take a long time to grow. But it can also come from cloves. It has been synthesized from corn syrup, rice bran, but also spruce trees and petroleum products, actually. We go to the next slide. So when I taught this class at the university and was starting, you know, of course I had some wisecracking little high school boys asking me about beaver butts. And so, and some of you may know, but there is a chemical called castoreum that is isolated from the anal glands of beavers, and it smells like vanilla. And it is actually what is used a lot of times in scented candles that are vanilla scented, in some of those other substances. It's not used in this country as a vanilla extract. So that is, and you can see the little post up there from social media, vanilla extract, imitation vanilla, and beaver butts. It is not, we don't use that in this country, but it does contain vanillin. So, I mean, it contains the vanillin, so then obviously that's where the smell comes from. So just so you're aware that that is out there. All right, next slide. All right, so I've been passing around trying to get ahead. We're going to smell the two samples. And then if you're interested, I was at first going to try to make some sweets with the vanilla, and I couldn't get them to quite not be as sugary. So instead, I just whipped up some whipped cream with some vanilla. So if you're interested, I have two samples of whipped cream that I'll bring around, one with the vanilla sample number 1 that you all have, and one with vanilla sample number 2. And that's where we're going to taste the compounds. All right.
No one
So I hear one is sweeter than the other. Second one has an aftertaste. So we have the first one is the real one. The first one is the real one. The second one is the artificial flavor. So, yeah. So, and they do match in terms of the odors as well. I mean, 1 and 2, I labeled them the same.
Is that the same with the smell?
That's the same with the smell. Yeah.
And I had that.
So number 1 was the real. Number 2 was the artificial flavoring. That's the same with the smell. Yeah, I kept them the same so that we wouldn't get confused. All right, any questions or thoughts on that? The first one tasted a lot better, yeah. Well, it has more in it than the second one does, because you're isolating other things from the plant in addition to the vanillin. So.
I'm never going to use the imitation again.
Yeah, I only buy the imitation when I'm teaching this class, to be honest with you. So.
Miracle Whip?
No, Miracle Whip, I don't like Miracle Whip. No. Miracle Whip, I mean, just, oh no, this wasn't Cool Whip, this was real whipping cream. Yeah, this was real whipping cream. It was 3/4 of a cup of whipping cream, 3/4 of a teaspoon of the flavoring, and a tablespoon of powdered sugar. All right, we'll go to the next slide. All right, so on your plate, you have a piece of pie. Eat your pie. Now, if you have any allergies, it does contain butter and it does contain gluten. So if you have any other allergies, let me know, and I can tell you before you eat it. And you're gonna figure out what kind of pie it is. And there's no nuts in it. Apple, cinnamon.
Lemon.
Brown sugar. Lemon. Lemon is the only fruit that's in it. If you go ahead to the next slide, I'll tell you what it is. It's the Ritz mock apple pie. So it's Ritz crackers, water, sugar, cream of tartar, lemon juice, butter, and cinnamon. Nothing. The back is another activity. This was just, this you didn't have anywhere to put a note about this. But. So this recipe I think goes back to, it's either World War I or World War II when apples were in very short demand and trying to find an alternative to still have a dessert. And so we have the mock apple pie. And you can actually make mock apple sauce, same sort of thing, just heat up some water and crush up some Ritz crackers, add a little lemon juice, sugar, and cream of tartar, and it kind of can trick your brain into thinking that it's apples. Yep.
Does the cinnamon fool you?
It's the cinnamon and the acidity. The lemon and the cream of tartar gives you that bitter, and then the sugar. It has a fair amount of sugar in it for the sugar of the apples. And if you leave the crackers partially intact, it sometimes can look like slices of apples to trick your brain into it. I had a hard time cutting it, so you don't really fully see that, and cutting a whole pie into 30 little pieces is a little bit of a challenge.
It definitely was not apple slices.
Yeah,
It was apple tasting.
but it's apple tasting. Yeah. All right, next slide. All right, so artificial flavors again. Actually, I guess I put advances on there. I didn't realize if you just kind of, there you go. I mean, so what are some common artificial flavors? Why might they be used? I think we talked about one of the biggest ones is cost and availability. And then, is every artificial flavor identical to its corresponding real flavor? I think everybody in this room decided vanilla is not the same exactly. So, so we definitely know that there's some differences there. All right, next slide. All right, so I've kind of already gone through most of these things. So we're back to where we had talked about taste, aroma, nerve sensations. So if we move to the next slide, and I guess we have to advance, sorry. One more at least, maybe two more, because I somehow, let's see. There we go, perfect. All right, so what I'm going to conclude with, and this is what's on the back of your page, and we will still have to pass out some foods to you because some of them I wanted to keep cold, so you don't have all of these items yet. But what we're going to talk about before you start eating what's on your plate, flavor pairing. So the aromas of food plays a role in your perception of food. And the hypothesis was started by a molecular gastronomist, Benzie, who looked at what if the major flavor molecules in foods are the same, the food would smell and taste good when eaten together. So he started looking at a database of what are the major components in some foods and then started pairing them together. So if we go to the next slide, please. So there's a website you can actually get to called Food Pairing, and that website shows you some of the really interesting pairings, and in fact, one of them you're gonna try today is caviar and white chocolate if you want. They contain the same flavor molecules, but things like chocolate and onions, actually chocolate and rose contain very similar molecules. In fact, the American Chemical Society did a webinar for chemists recently for Valentine's Day on the chemistry of wine, roses, and chocolate for Valentine's Day, and they actually all share flavor molecules that are the same. So next slide, please. So as I said before, there's tons of molecules, and there's at least 10,000 different flavoring substances that have been identified from nature. The flavor industry uses about 2,500 of them in different preparations. Next slide. And so again, with this food pairing website, if you ever want to go on there, you can use this to kind of find how things match. So you can see that they put in brie, and it shows you with brie that it has a really good match with strawberry, or with yogurt, a little less with raspberry. So it would kind of tell you which molecules you could pair together. Next slide. And then, sort of related to your question earlier about culture, some of the things that they start to look at is, and this is from an article in Nature where they start to try to map out these flavor molecules and how do they connect. And they started to look at the flavor molecules in each of the compounds. I know it's very small on the left side and you can't really see that, but then starting to try to make connections. And you'll notice with the flavor network, we can see that parsley and scallops connect really well with garlic. And if you think about some of those foods that would have like shrimp scampi, or scallop scampi, or seafood scampi, would put those together. Next slide, please. And they started to do this even with more flavor networks. So as I said, these are very hard to see. I wouldn't expect that you could see all of this, but trying to profile these together. And then on the next slide, you'll be able to see that they started to look at cuisines of certain cultures, and we're able to see that connections are made between the foods that were put together, not necessarily knowing chemically why they put them together, but they figured, oh, these things taste good together, but they actually do pair together. Next slide. So on the back of your sheet, I've put some of the things that are on there, and so you'll be able to try the food individually and then pair it as I've suggested. So for example, start with a strawberry, and then celery leaf, and then mint, and then you could combine the strawberry, the mint, and the celery together. And as you're working on that, I'll bring by some of the other items that I was not wanting to put out until we got ready to eat them so they stayed cold. Any questions before I start doing that? All right, well, enjoy, and also see if you can figure out your own flavors.
I mean, how do you describe the flavors? Tastes like a strawberry.
Right, yeah, I guess that's true. It does taste like a strawberry. You may have to try to figure out if you have your own way to describe it. Is it sweet? Is it bitter? But does anybody need something because they accidentally ate something and didn't do a pairing? Yes.
Strawberries.
Strawberries,
Somehow
I can
ate
bring
them all
strawberries
and
around.
made a pairing.
And everybody else.
Discover any new pairings, anything interesting to you? Tomato and strawberry. Yeah, that's nice in summer salads if you think about it. Anybody else?
Blue cheese and pineapple.
Blue cheese and pineapple. Yeah, it's a nice combination that I wouldn't
Caviar
think.
and honey.
Caviar and honey, there we go, mixing some of the sweet and salty. Pineapple and caviar, ooh, okay, another one with kind of the sweet and salty and, absolutely. All right, so any other questions? I mean, you all have been great, you've been asking me questions that we've been going along, but any other questions?
I noticed that I tasted the cheese more in the back of my tongue.
Taste of the cheese more in the back of your tongue. Some believe that some of the, your taste buds do change based on location, but there's still some idea that perhaps they are more uniform, but maybe you have more of your umami senses is what I would think with the cheese, you're picking up the umami there. Yeah. Anybody else? Yeah.
So are there any receptacles on the underside of the tongue? I know that there are a lot of veins there, but...
Yeah, no, there's very few of the papillae actually on the underside.
Because one of the things that I do with like red wine is let it sit underneath my tongue, and it seems to...
Seems to make it, bring it out.
Yeah, yeah.
That's interesting, because I don't think you have a lot of taste buds down there. Anybody else? Any other final thoughts or questions or?
I just want to say how much I appreciate all the work that you do, the money you spent, and the knowledge that you have.
You are so welcome. It's my pleasure. I really do enjoy doing it.